Hello, and thank you for joining us today as we take a first look at XTDB v2. So my name is James, and I'll be your tour guide today. So with me, I've got Jeremy Taylor. He's head of product for XTDB. So before joining Juxt in 2019, Jeremy held a sales engineering position within IBM, working on e-commerce systems. And for over a decade now, he's been fascinated by relational and non-relational databases, and is motivated by the promise of data abstractions that can improve developer productivity across domains with frequently evolving schemas. So as for me, I'm head of engineering at XT. I've also been working on XT since 2019. So before that, I held engineering and leadership roles at companies both very large and very small across a variety of business domains. And eventually I figured out that a lot of the domain complexity I've faced all had time in common. So I came to Juxt to help write their bitemporal database. And now I'm here talking to you. I think, as they say, the rest is history. So for those of you coming across it for the first time, XTDB is a document-oriented, dynamic, bitemporal database, which is queryable both over HTTP and an in-process API. We do have a stable release available. It's version 1, and it's been in production use in a wide variety of business domains for a good few years now. So V1 is predominantly queried using Eden Datalog, which is a variant of Datalog originally made popular by Datomic. And it's become a de facto standard really in the Clojure ecosystem. But this year, in addition to the usual sort of performance improvements and bug fixes for V1, we've been hard at work on its successor, which we're rather imaginatively calling XT2. And we're pleased to now be at a point where we can share it with you for your initial impressions and feedback. So coming up, we'll talk a little bit about what's involved in XTDB v2. We'll run through an interactive introduction to XTQL. We'll talk a little bit about the life cycle of XT2 data from transaction all the way through to query. And we'll talk about how you can get involved in the journey to general availability, or GA. So what can you expect from it? Well, we have 3 main aims. So first, it's a hybrid and transactional analytical processing database, or an HTAP database. So XT1 is a great transactional database. The indices that it keeps are highly optimized for this use case. In XT2, though, we've improved the support for OLAP queries to reduce the need for users to write and maintain ETL processes out to a separate OLAP system. So as part of this, data in XT is all now stored in the open Apache Arrow format. And we also now have a shiny new dynamic columnar query engine. Additionally, we've also decoupled data storage from the compute nodes. So currently in XT1, we effectively require all of the data to be indexed on every node in the cluster. In XT2, though, we relax this constraint. So when a user makes a query that requires data not already present on the node, it fetches it from a shared object store. So for example, something like Amazon's S3. And this means that infrequently accessed data, so for example, like the full history, naturally falls out of a node's working set into cheaper storage and allows XT clusters to work with much larger data sets. We also have what we call across-time bitemporal queries. And so XT1 is great at point-in-time queries and can also return the history for a single entity. XT2 additionally supports fully general bitemporal queries. So this is including things like across-time aggregations and temporal joins. And finally, the addition of first-class SQL 2011 support. So as you folks will know, we love Eden Datalog, and particularly the benefits of its data-oriented queries. And we find it an absolute pleasure to use from the REPL. But it's hard to deny the position of SQL in our industry. So as Rich might say, Datalog rocks, but SQL reaches. There's such a wealth of knowledge, experience, and tooling for SQL that it seemed a bit foolish to be Datalog only. So XT2 has first-class support for 2 query languages. One is SQL, and the other is XTQL, which I'll come on to shortly. Regarding the pronunciation of that, we're not really too fussed. So if you pronounce SQL, then XTQL is fine. If you pronounce it SQL, then I guess XTQL's fine. STQL, maybe not. Maybe not. The SQL 2011 standard introduced a specification for bitemporality in tables and queries, which we've implemented. But crucially, though, data inserted via XTQL is queryable with SQL and vice versa. So if you have developers preferring XTQL and data analysts preferring SQL, they can both work with exactly the same data. In bringing USQL, one of the major changes we've made in XT2 is that your documents now will live in specific but dynamic tables. And in keeping with XT's dynamic nature, these tables are best thought of as bags of related documents, the same as you would in a SQL database. But there's no requirement for upfront schema, and no requirement at all, indeed, for all of the documents in a table to have the same column types or even the same columns. So this obviously helps us with the XTQL SQL query interoperability, but it does also give us internally, it also gives our query planner more fine-grained stats on the shape of your data, with which it can then make better query optimization decisions. So as I say, the other query language is XTQL, and this is our new language specifically designed for use in XT2. So what we're looking to achieve with that is this. So firstly, a data-oriented query language, amenable to being both written and generated. So as an industry, we believe that we've all spent way too much time trying to generate SQL strings, not to mention all of the security issues that come with it. Secondly, a composable query language, consisting of small, simple building blocks that can be easily combined into larger queries. So these two aims contribute to what we believe is a joyful REPL experience, with the ability to build queries iteratively, testing and debugging smaller parts in isolation. And hopefully you'll see some of this shortly. We also wanted a query language that naturally translates into JSON. So while we obviously still love Clojure and Eden, and will continue to support them, we recognize the ubiquity of JSON. And finally here, a query language that's easy to learn for users familiar with either Eden Datalog or SQL. So ideally, if we've done our job right, anyone with experience in either should be able to at least read an XTQL query and have a good feeling for what it does. And in a similar vein, it should be relatively straightforward rather, for users to mentally translate back and forth. So XTQL is a data-oriented, composable query language that's heavily inspired by the theoretical basis of both Datalog and the relational algebra. All right, time for a live demo. So for those of you that want to play along at home, I'll give you a moment to follow the instructions here. And I think if Jeremy could paste these into the chat, that should make them easier to copy.
There's a small hiccup there where I can't seem to enter into the chat. Sorry about this. XTDB / Secular Playground will get you there.
Can I do that? I can't copy and paste from that at the moment. Let's go for this. GitHub.com, XTDB Secular Playground.git. There we go. How's that?
So I can see that, but it says only to hosts and panelists. So
take two. Yeah. Apologies. 2. Yeah, I can only send it to hosts and panelists as well. Dee sent it to everyone. Thanks,
Dee sent it. Brilliant.
All right, I'll just give folks a moment to get that downloaded. Actually, while we're waiting, I do distinctly remember one live demo. It was at one of my my first conference talks, a Clojure Exchange in London. I think we're probably talking, actually it is 10 years ago now. I naively thought it'd be a great idea to give a live demo that depended on the very early ClojureScript dev tooling, and safe to say it went wrong. I got an error message that just said broken pipe. So I restarted everything and same again. And actually my second mistake that day was to ask the audience if anyone had come across this before and knew how to fix it. To which someone in the audience helpfully shouts out, "Have you tried a plumber?" Anyway, thanks for coming today, Chris. It's good to see you, mate. Very reassuring to know you're on hand if something goes wrong. All right, let me grab my Emacs up. It wouldn't be a Clojure demo without Emacs. All right. So, Jeremy, just to confirm, have I got my Emacs up on screen?
Yep.
Excellent. All right. So what we do then, we'll just run through an introduction to XTQL, and hopefully if you're in the user namespace in the Secular Playground, you should be able to play along with this at home as well. Looking at this now, actually, and this is why I'm not in marketing, because at this time of year, I very much could have got away with talking about this being an advent calendar. I guess I'll stick to the engineering side of things. Let me stick both of those over there so I can actually see what I'm doing. All right, so we've got our first query here from the Sequila data set. So the Sequila data set, it's a theoretical video rental store. That shows my age, doesn't it? Where we got a catalogue of films, the actors that starred in them, and also customer details, and what those customers have rented. So we'll focus to begin with on the films table. We'll have a quick look at what's in here. So if I evaluate this, we'll get all of the films that are in the database. And again, we're just seeing the SQL here. Now, as I said, we can actually submit both of these to XTDB on the same data, and hopefully you should see that they're relatively similar queries too. Right, now for the game to start off. So let's see if we can replicate this in XTQL. So this introduced our first operator. Our first operator is called from, and this allows you to select data from a table. So in this case, I'm going to ask to be selecting from the film table. And the three fields that I want to bind out are title, length, and rating. So if I evaluate that in the same way, we should get, looking over here, we should get a very similar data set. So I've got, I'd say there's some great generated names in here, isn't there? Westwood Seabiscuit, good God. Okay, so that's how to do a very simple select query. What's behind our next advent calendar door? All right, next up. So that's obviously quite a lot of films. I think it's about 1,000 odd. It is exactly 1,000. That's obviously quite a lot. So what we'll do is we'll evaluate this and we'll try and limit them to just 10. So that goes without saying in SQL. What I'll do is I'll just keep hold of this XTQL query. What we're doing now is introducing a pipeline. So this is the fundamental unit of composability within XTQL. So we take the result of one query, this from film. We can now pipe it through various other operators, using what to Clojure folks would be quite familiar as a thread first macro. It's not actually a thread first macro. Don't tell anyone. It's more to keep up with the idea that you start off with one data set and then pipe them through a series of transformations. So in this case, I can add in order by. So that gets me those as ordered by title. And then finally, hopefully in a surprise to nobody, I can also do a limit 10, which will give us the first 10 of those. So this is how we compose XTQL queries together. Next up, what have we got? We've got a filter. And so what this is doing, we're looking just for the film African Egg. And we also want to have a bit of an explorer of this data set. So we're going to ask in a fairly traditional way to select star from that film. So what I'll do, I'll just go back to this query. And instead of title, length, and rating, what I'll do is we'll first filter by title. So I'm adding a map in here to do that. African Egg. And I'll also, within this vector, I'll ask for star. So what have we got? So here's the document. It turns out it's a fast-paced documentary of a pastry chef and a dentist who must pursue a forensic psychologist in the Gulf of Mexico. Wow, there's a Christmas watch for you. I should say these are generated. Don't go looking them up on Netflix or anything like that. Okay. Similarly, as in SQL, we can use parameters here. So anyone who's written any kind of SQL queries will be familiar that when we're passing user input into these, it's best practice to include these as a parameter, so that the user can't drop all of your tables. What we'll do here instead, so again, in XTQL, parameters look fairly similar. The difference is that they're named instead. And so in this case, I'm going to bind title out to the $title parameter, and I'm going to pass in args of African Egg, and hope that gets me the same thing. It does. I'm just going to take a very quick glance at the Q&A, just in case.
All quiet so far?
All quiet so far. Excellent. Now it begins to get serious. Okay. What have we got? So this is our first join by the looks of this. So we've got films. We've got a traditional join table, which is film actors, which is a many-to-many join table. And then we've got the actors table. And what we're doing, we're joining on film ID and actor ID. So it looks like film actor rather. This one here has got a film ID and an actor ID. But we're in XT and I have a REPL. Shame on me for not thinking that I couldn't just do some kind of check to see what's in there. So we do from film actor star. I'll just grab 10 of them. What does it look like? What have we got? We've got actor ID, we've got film ID, and we've got a primary key in there as well. Cool. Okay. As we expected. Right, so I'll use this from film actor. That's handy. We'll grab the film ID and the actor ID out of it. But now I need to introduce another operator, which is how to bring in multiple tables in XTQL. And this is where those of you familiar with Eden Datalog will really notice its Datalog heritage, because we start off with a unify operator. On its own, doesn't do an awful lot, not very exciting, with just one single input. But where it really comes into its own is that this can then take a bag of inputs and joins them all together. And it joins them all together using what we call unification constraints. So where I've requested film ID and actor ID out of here, if I also pull in, for example, the film table, and I bind the XT ID into film ID, what I've now done is introduced a unification constraint or a join constraint that says that the film ID from film actor needs to join against the XT ID from the film table. And then likewise, I can do the same on the actor table. I'll add another one into my bag of inputs, but this time the XT ID on that table is the actor ID. What else have I not done? I've not filtered it down to African egg again, like that requested. African, it would help if I could type, wouldn't it? African egg. There's 5 of them. Let's check against our original results. Yeah, so we got 5 of them there. And we've got first name and last name. We've got title, length, and rating. So let's pull title, length, and rating out from here. And I wanted first name and last name from actor. Excellent. So hopefully you get some kind of sense here about the sort of the REPL-driven nature of XTQL here. We've gone for exactly that same feeling that we all know and love from Clojure development, and wanted to apply that to querying the database as well. And particularly for those of you familiar with it, the structural editing that you get within your editor as well. So all of these are manipulatable in the same way that you would any other Clojure data, any other Clojure code. Cool. Let's just quickly do a check-in on here. Did I mention the minimum required version of Java? No, I didn't. It is 17 for the in process and 11 for the client. This one's in process, so it'll be 17. And I think that's about that for now in terms of the demo itself. All right, what have we got? What's changed here? Aha, we've got a projection. So in this case, we're now saying that the first name and last name, we want to project them out in a relatively traditional way, putting a space in the middle here. So in SQL, we do that with the concat operator. So we'll see what we're looking to get there. All right, so we've got a name, which is concatenated together. So again, I'll reuse this query, and we'll introduce another operator, which is called with. And in this case, I can say that the name is a concat of first name and last name. Note here that the standard library that we're including with XTQL is actually closer in names to SQL, and this is again to try and keep the two query languages as similar as possible. So you may well notice, if you are familiar with the Clojure standard library, that would be str, but we're using SQL names here. So that's that. That's adding the projection in. I've still got the original names in there, which I probably don't want. Now in SQL, we project those away in the select clause. In XTQL, we can use without. So we can say without first name and last name, and that'll do the same kind of thing. If it's easier for us to write down what we do want, then we can use return. So in this case, it's film ID, title, length, rating, actor, ID, and name. And then that should hopefully give us the 6 fields that we wanted in the XTQL. Okie dokie. I know what's up next. Right. So the requirement in here then comes in that actually I don't want this to be a flat relation. Right. Because when I've got a flat relation, I'm duplicating a lot of the fields from the parent entity. So in this case, the film, for every row in the table. And there are sort of myriad reasons why you might want this as a tree rather than as a flat relation. So again, for those familiar with any of the Eden Datalog databases, in those databases, this is done with pull. So you specify a pull spec, and it'll then essentially pull the data out from the database for you, based on a given start node in the graph. In SQL, I did actually have a bash at doing this. It's for one level of nesting, it's not too bad. We're dealing a lot with array ags and object, which is an XTQL built in to build a map in a SQL statement. But I'm sure, as you can imagine, if this gets nested by more than one level, this starts to look pretty hairy. So I say, my challenge for now then will be to replicate this in XTQL. All right, so I've got this query from above. It's not far off, so we'll start with it. We'll move from here. Okay, so at the top level, what did I want at the top level? I wanted the films at the top level, didn't I? So what I'll do, just for now, I'll take this out to the top level, and then I'll comment these two out. And that just makes sure that we get back to, that looks like we're getting back to something that we want. I then want to use with to project out the actors column. Now, what I'm going to use is another XT built in, which is called pull star or pull many. And this is for when I want a vector from the subquery. So here I want to get a whole collection of actors. If I only wanted one, so if for example if film to actor was a one-to-one relationship, I'd just use pull. But in this case, it's a one-to-many, so we use pull many or pull star. Now what I should be able to do, here's one I prepared earlier, is grab the unify from the subquery from within there. And the only other thing is I now need to specify how to join the two together. So what I'll do, I'll make film ID a parameter instead. We'll pass that in as an argument into the subquery. And we'll see how that goes. Excellent. So here what we've done, we've repurposed part of the query in a subquery instead. We've literally dragged and dropped the S expressions into place, and now we've got our nested results. Only trouble is though, we've got too much because we also don't want actor we don't want actor ID, we don't want last name and first name, same as before. And here's where XT2 pull differs from XT1 or indeed sort of Clojure standard pull. Because here we're using a full subquery, we get an awful lot more bang for our buck here when it comes to what we can pull and what we can do with that. First of all, actually, one that I even glossed over was that we can go directly from the film to the actor table. So I think in this case, if you had separate documents in other Eden Datalog databases, you would have needed to do 2 levels of pull here. Whereas again, because we've got full queries here, we can do it in one. We get a lot more control over the output values. Again, probably no surprise, I can chuck a pipeline in here. What do I want to do with that pipeline? Well, I just want to, well, first of all, I've asked to order by last name, so I'll do that. And in this case, I actually only want to return the name from the inner query. And so if I now execute that, I get pretty much, yes, the same thing, but in a slightly, with the parameters in slightly different order. With the attributes in a slightly different order, given that it's in a map. Cool. All right, we'll move on to the next one. I won't be going through the entire XTQL manual here. Obviously, that would get quite boring, but we've got to. I'll run through a couple more, particularly here aggregation, as it's quite a common use case. All right, so this query here, it's looking for the counts of. Let's have a look. It's looking for counts of how many films each actor has been in. So we're looking at the actors table. We're joining on the film actor table, the many-to-many join table. We're then grouping up. We're counting for each actor. We're ordering by the film count descending and limiting 5. So again, for us, this means introducing another operator, which is the aggregate operator. So I'll start off with a unify. Have I got one that I can use? Probably not worth me dragging one out from the top there. So we'll grab it from actor. In this case, we need XTID actor ID. We want to project out their first name and their last name. We then want to introduce film actor into the bag. So we'll do that. We'll bind actor ID so that it joins against the actor table. And that's actually the only thing we need from that, because the next thing we want to do is aggregate this up. So we'll group by first name and last name. Grouping, as in XT1, is implicit here. So the grouping columns rather are implicit here. And then we'll also project out the film count column, for which we'll use row count, the built-in row count. Let's see what that does. That's looking rather hopeful. Excuse me. So we've got a whole list of their actors. We've got all of their film counts. Also in the requirements here, we're to order by the film count descending and to limit us to the top 5. So that gets us 54. Actually, I'll just comment that out and let's see whether they're the same top 5. That's looking quite good. So we can see that they're sort of descending. If I uncomment that now, we'll just take the top 5. Nice. We've got one more in the bag. Aha. So what this one is doing, as it's asking, so we've got the in our query above here, we've got all of the film counts for each of the actors. What this one is asking us to do is to do a frequency distribution of those film counts. Now in SQL and again in Eden Datalog, this actually requires you to use subqueries, and this is because that when you have SQL queries or Eden Datalog queries, whenever you need anything from the top level framework in SQL, the select from where, in Datalog the find where, you need to include the whole frame then as another subquery. But because XTQL is all about transformations on a pipeline, we can now just, and I use that word sparingly, we can just add another aggregate into the pipeline. So this time I'm aggregating over film count. We don't actually need first name and last name anymore, so I can just do it on actor ID. And then when we aggregate that, we get the frequency here. And so now I've got a what looks like a frequency distribution, albeit not a very hopefully organized one. So I'll order by film count. And then that should show us that we've got one actor with 14 films. We're going all the way up. Where's the max? We've got 19 actors had 25. And then all the way down to the maximum element, which is one actor who's been in an astonishing 42 films. All right. I suspect that's probably a good point to take a quick break. And we're going to have a quick look at the Q&A. Maybe Jeremy
Yeah,
can
so
help at this point.
yeah, we had a question from Martinez. He asks, does V2 index lists like items like it does in version 1? Or do we need end-to-end join tables?
That's a great question. And actually, we do allow list entries and also set entries as well in your documents. The main difference here is that because lists and sets are now first-class values within XTQL, like we've got a whole load of standard library functions like nth, first, last, all of the kind of functions that you'd expect to see on sets and vectors. What we didn't want to do is to introduce the same kind of implicit unnesting that you get with XT1 and with Atomic. So we do have an explicit unnest operator as well.
Okay, great.
Shall I can probably demo that.
Yeah.
Am I going to regret going off script here?
Do it live.
Without a shadow of a doubt. We'll find out, shall we? So film, if I recall correctly, has, I'll limit that to 10 because otherwise that might blow my REPL up. Film has a set in it called special features. There, so you can see behind the scenes, deleted scenes. So all right, let's tell you what. Let's actually just bring in title and special features. So what we've got behind the scenes, deleted scenes, commentaries. Okay. So what we can do here is that we can then, if I unnest, I'll say feature for feature in special features. That should then give me title. So I'll just return title and the feature. Oh, boo. There we go. Not bad. So we've got Anthem Luke, which has got a couple, but we've now unnested them out. So we've now got one row for each of the special features within the set.
We're done.
Yeah. Only one.
So Martinez also asked, is the query result always an eager vector?
So it is in this case with XTQ. We will be introducing options to this API, which will allow you to stream these results. The query engine itself is very much I call it a semi-lazy query engine in that it works on batches, but sort of relatively small batches, like 1,000 or so. So if you've got a massive result set, it'll stream them out about 1,000 a time. If you haven't, obviously, you'll get the whole lot in one go.
Thank you. So I'll just do a couple more questions, otherwise well, I'll have more interruptions later. So Robert asks, how did you load the data originally? What does that process look like? Maybe it's worth a 30-second detour.
Yeah, absolutely. So how I loaded the data initially, you'll like this one. So I got hold of the Sequila data set, which is on the MySQL website. I inserted it into MySQL. I exported it out into XML of all things because my MySQL experience isn't that great. I then put them into Eden file, transform those into Eden files, which live in this Sequila repo. So we can have a look at the film.eden, which is essentially just a big Eden file. Then within the Sequila dataset, I've got these two functions at the top here. One of which is to submit a file, so that reads the file line by line. Relatively sort of standard Clojure for that one. And then finally, when the node started up, it just inserted all of the data into it.
Perfect.
And very much a playground.
Yeah, and all of that is in the repository. So
it is. Yeah.
Feel free to study and ask questions later. Andrea asks, one comment about unify is that the variables you are unifying are not usually distinguishable from other field names. Should they I guess they should not be keywords since that's different, but maybe there could be some other convention to distinguish them. So,
So there's the use of symbols here.
yes, I think so. Yeah.
Yeah, I think so in this case, we've played around with quite a few different quite a few different iterations here. And I think we chose to keep with symbols here and to be in keeping with a lot of the sort of the Eden data log history. So the idea here being that anytime you see a symbol within a unify, it's something that can be unified. And when we rename a column, because the attributes within a document are at the moment at least keyword keyed, or can be thought of to be keyword keyed, we thought we'd separate those out. But yeah, there's I can see why it takes a little bit of getting used to, but to say hopefully after a few queries it should become second nature.
Cool. And there's one more question, which maybe you can just show live quickly. Chris asks, can you use XTQL against static data sets? I'm thinking for testing, can I just query against a fixed list instead of data stored inside XT? So I think you know what I'm thinking of.
So this is using the rel operator. So we've got a couple of source operators. One is from. One is unify, believe it or not, because unify can source data. But the third one is rel. So in this case, I'm going to create a relation that's got A's and B's in it. A3, B4. And let's say I want to join that against another table. So I'll bind B out in this case. So I get my B's here. I can use this within a unify. So that behaves just like any other relation in a composable way. But I can also pass this in as a parameter to the query as well. So if I call that my rel, that I then get the same relation out at the bottom.
Brilliant.
Let's see if I can just do where greater than B3. Yeah, there you go. I'll bind both of them out. So I'm only now getting the row where B is greater than 3.
Very good. Okay, James, I'll let you continue.
All right.
There are a couple more questions then, but yeah, let's come back.
All right. In which case, then let me shuffle on back to the slides. That'll be a may. Can I just get you to confirm, Jeremy, you can see the slides again?
Yes, I can. Yeah.
Brilliant. Awesome. All right. So XTQL also does support DML, and we've not talked about that much in the presentation. And this has the full power of the XTQL query language. So in this example here, you'll see that the SQL one is updating a name. Obviously, it's updating all of the Susans into Sus. We'd probably put another filter in there, like an ID filter or something like that. But in this case, let's say we do want to update them all. And you can see here we've got an equivalent in XTQL now as well. So we bind out to filter against the first name, same as we would do in a query. And then we specify to set the first name as Sue here as well. And secondly, we can also increment values already in the document. So in this case, let's say we've forgotten what we actually wanted to do was bump a version number. I'm saying bump a version number. Obviously, this applies to any time you want to update a value based on the value that's already in the document. In this case, where we can bind out the version into a logic variable, and we can then use that logic variable as part of the set. The idea being here that this actually obviates the need for quite a lot of what would previously have been transaction functions into more ad hoc DML queries. So no need to pre-register or anything like that. We do still support transaction functions, but I would highly recommend using this DML if at all possible. And finally, on the XTQL side, we'll talk about sort of dynamically generating queries. So I talked earlier on about how we wanted XTQL to be amenable both to writing queries by hand, and hopefully we've shown that through the demo, but also generating them. And here, we demonstrate a use case where we might have let's say we've got an HTTP request comes in, and based on query parameters, we want to sometimes return additional author data, and sometimes we only want to filter to where to posts that are popular. And so what XT template allows you to do is to use Clojure's unquote and unquote splicing in your queries. You don't have to worry about syntax quoting or anything like that. And I say this is heavily inspired by Brandon Bloom's backtick library. So thanks very much for that one. So in this case here, what am I doing? Well, as part of my initial from, I need to conditionally project out the author name. And I need to conditionally project out likes as well, if indeed we've been asked for popular posts. And then if we have been asked for popular posts, I then have to add a where into the pipeline to say that the posts that have more than 100 likes. All right, I'll move on to talking about the life cycle of XT2 data. So one of the first big difference here is that we're now predominantly recommending the HTTP and client drivers as the recommended means of production access now. A couple of reasons for this. So firstly is to scale XTDB independently of your application itself. It's a more traditional database deployment pattern. But also because XT2 now benefits a lot more from longer-term local caching, both in memory and on disk. So wouldn't want that to clear that out at the same rate that you're deploying your application. We do still maintain the in-process version, as you've seen from the REPL demo, and we still absolutely love it for testing and interactive development. I think it's second to none in that respect. On the what then happens? So the transactions, in a fairly similar way to XT1, get written into the write-ahead log, into the transaction log. One big difference here is that this is now transient, so there's no need for infinite retention now on your Kafka log, which is one constraint that we particularly eager to lose. And secondly, is that the data on the transaction log is now all arrow format as well. And so I talked about Apache Arrow earlier. I just want to take a brief detour and talk about why we've gone for Apache Arrow, or the benefits that it brings us. So first of all, it's a columnar format, so all the documents are broken down into attributes. I'll defer you to Jeremy's webinar from the other week to talk a lot more about columnar, its benefits, and a lot more about sort of the wider ecosystem. But particularly here, the benefit that we see is the faster lookup for individual values and column scanning, especially when it comes to fixed width primitives. Arrow itself is off heap, so it's manual memory management on our part at least. But in terms of the sort of the health and hygiene of the JVM, this does mean for significantly reduced GC pressure. One of the big performance benefits we've seen though is that with Arrow, it's been deliberately designed such that the disk layout is the same as the memory layout. And what this means is that there's significantly reduced serialization and deserialization overhead. We can pretty much work with the bytes directly as they are on disk. One downside is that it's harder to update, but I say thank goodness we're in an immutable database, and those same principles then also apply to the files that we write as well. I was going to talk a little bit more about the actual structure of the vectors. I'm more than happy to talk about that afterwards, but I'm very conscious of time. So running back through the life cycle. So again, similar to XT1, we've got an indexer which lives on every node. This reads the write-ahead log and then spools it to our new object store in large blocks. So the object store might look similar to a V1 document store, but this is now for much larger objects. So we're talking probably in the order of magnitude of about 10 to 100 megs each. And as such for this, we'd now recommend S3, Google's equivalent, Google Cloud Storage, Azure Blob Storage, NFS, all of those kind of sort of file stores, rather than perhaps the JDBC object store that we have currently on V1. This indexer currently happens on every node, so that the blocks that it posts into the object store are still deterministic. And this provides the live index as well to the query engine. So this arrow back to the left into the query engine, and this is data that hasn't yet been written to the object store. The structure that actually gets written into the object store is you can kind of think of it as an LSM tree, a log structured merge tree. we've adapted this for bitemporal data. So a log structured merge tree seemed like the absolute natural thing for us, given that we are storing the entire history of your data. But we do also want to optimize very much so for queries at the current time. We're assuming that this is going to be like the vast majority of your queries are going to be queries at the current time. And so the LSM tree helps us out here by bringing that data front and center, making it more available. So it's the compactor's job to do this. Now, this work is actually shared between the nodes. So the indexer's job, the deterministic part, is actually a relatively small proportion of the work that needs to get done now to maintain this object store. And the vast majority of it can be shared between different nodes, which means as you add more XT nodes, the more compaction can happen, and the better shape the indices on the object store will be. Finally, we've got the query engine. So this pulls from both the object store and the live index in order to serve queries. And this now stores as much as it can in memory and local disk caches. Zooming in now on that query engine, there are several stages to an XTDB query, and each of them very much do one thing well. So firstly, we plan both SQL and XTQL to an intermediate representation. In this case, we call it the logical plan. And this essentially papers over the difference between the two, so that as much of the query engine as possible applies regardless of the source query language. At this stage, we're talking about an unordered bag of joins, so like in the unify operator, or extracted from an SQL from join clause. So even though an SQL from join clause does have an intrinsic order to it, we then remove this order so that we can plan it, so we can plan the join order. We then optimize this down to a physical plan. So now we've chosen an order for the joins and the selections, but we've also applied a number of other optimizations. So this was one of our bigger behind the scenes wins in V2, because actually there's an awful lot of academic literature we've been able to lean on here. And one big example here is decorrelation. So when a SQL, or indeed an XTQL subquery, refers to a column from the outer query, so with no decorrelation, you've got no choice but to execute this as a nested loop join, and essentially running the outer query then for every row of the outer query, executing the inner query. And some of you may be familiar with this as known as the n+1 problem. Decorrelation, though, allows the query planner to reorganize this query so that the inner and outer queries can be run once and then joined in the usual way. So we then compile this physical plan into relational operators that are very much optimized for columnar batches. So these are operators like scan me a table or project me this column, etc. And any expressions in that query, so like we saw where plus version 1 was a very simple example of that. Any expressions in the query are also compiled into vector operations so that they can run on whole batches at a time. And then finally at the bottom, out pop the query results. So naturally, a question we always get is around performance. And I'm going to sidestep this one a little this time, I'm afraid. The reason being, this last year has all been about getting XT2 working to a point where we can get a first milestone in the hands of our community, get them playing with it over Christmas, and respond to their feedback. And while that's happening, we can then focus on the performance. And performance improvement really in a database is a continuous and indeed some may say never-ending process. But given it's Christmas, I can share with you a few little early indications of our performance here. So next year, we'll be particularly looking at the OLTP side of things. So we spent quite some time this year optimizing the hot loops within the batches themselves to get us to this point. But for the smaller queries, we naturally notice the per query and per batch overheads are being a lot more. We've also got more work to do optimizing our cold reads, and obviously work like tuning cache policies is never finished. So what's next? So first and most importantly, we're very much in listening mode right now. And thank you to everyone in the community who's gotten involved so far in our smaller focus groups. So they can attest to the fact that XT2 has already come a long way compared to what we first showed them. And it's in no small part due to their insight, experience, suggestions, and bug reports. So thank you guys. So please do give it a try. Getting started info is all on our website. There'll be a link on the final slide, and do have a play with it over Christmas. And then get in touch. So positive feedback goes on our public forum at discuss.xtdb.com. Negative feedback goes to our private mailing list at hello@xtdb.com. I jest, of course. Either is fine. It's up to you whether you want it to be public or private feedback. So next year is all about the road to general availability. Our main focus will be on everything that's required to make it production ready and at scale. So performance, stability, and operational considerations. Secondly, will be client libraries, and there's no reason this can't be more accessible outside of the Clojure ecosystem, especially with the JSON dialect of XTQL that's coming soon. And then other features, as you can see here. So finally, I'd just like to say a big thanks to everyone at Juxt who's worked hard at making this happen. So you will get the opportunity to see Jeremy's and my beautiful faces on a semi-regular basis. But these fine people are the unsung heroes behind the scenes. So thank you to all of you guys. And thank you for joining us. I'm happy to take any questions. Cheers.
That's brilliant. Thanks, James. So we do have quite a few questions. Let's start with an easy one. Mark asks, does the architecture imply that data is queryable as soon as it's available in Kafka?
Near enough, and certainly much nearer than it has been previously. So what happens here is that in fact, let me see if I can grab that back up again. Where's that gone? This one here. So what happens here with the write-ahead log is that the work that needs to get done is in the indexer here. It needs to pull it off the write-ahead log or Kafka, and then into the live index. And at that point, it's then queryable within the query engine. So not a lot of work to do there, but it is still fundamentally asynchronous. And for this, we use what's called a transaction basis. And this is so that you can any writes that you make when you submit a transaction, your client on your behalf will ensure that write is available to read before it returns any more queries.
Great. Martinez asked, is the consistency model linear? Will you consider moving to sequential model to process the log per table rather than fully sequential ingestion?
It's stronger than linear at the moment. We've actually got the top consistency model, strongly serializable, as you probably guess from the write-ahead log here. Will we consider the move to sequential? Potentially. I probably wouldn't do it per table or per row. We've talked about doing it per partition, and giving the user a bit more control around what that partitioning model is. But they're very early days discussions as yet, so I definitely don't want to make any promises on that one.
Brilliant. Okay. Sagar asks, with HTAP, is V2 suitable, or will it be suitable for reporting purposes? Does it, how does it, or does it, or should it approach the problems of efficient pagination, ordering, and filtering using both top-level and deeply nested keys, even with an unstructured schema?
So yeah, we're certainly hoping that it'll be suitable for reporting purposes. We see quite a lot of, Juxt see quite a lot of systems in the wild where there is a necessity for separate ETL processes to get data from your transactional systems into your analytic systems. And we're hoping that XT2 can get into that sweet spot with HTAP. So certainly for enough use cases that makes it valuable. Of course, if you're dealing with very, very specialist stuff, we're not going to be able to be the best in the world at both. So there are some trade-offs involved in that. But hopefully there's enough room in the middle ground for us to be quite comfortable. Is it suitable for reporting purposes though? So efficient pagination, ordering, and filtering. So all of the, especially with regard to nested data, we do now index nested data. We at least keep metadata on what's in those fields. So if you do have nested data within your documents, when you're filtering by values in those nested keys, we can use the metadata on each of our disk pages to know whether that disk page is something we need to read for this particular query. There is a degree within XT2 that scanning arrow files is just so fast that we sometimes make the decision to scan more than we need to, rather than trying to be at all clever about what we read. There are some cases where that does become faster. The game that we have over the next year is about figuring out which case is which, but that's very much a query planning optimization work to come. Just check I've answered all of that. I think so.
Yeah, I think you covered it.
If not, please do follow
up. Just back to the architecture, Alexander asked, is the write-ahead log partitioned?
So at the moment, it's a single partition. Again, same as XT1. We're talking about how we might move to multiple partitions at the moment. Again, I can't make any promises on that one.
Yeah, that's good. So we've had a couple of questions around deployment ops, migration version 1. I guess our current position is that, please try XT2. We definitely want to work with sponsor users. But Robert asked earlier, for instance, I'm working on an app to be finished this month with V1, but would love to use XTQL. At what point can I seriously consider migrating? So we would like to explore that with you. I think for different use cases, we can judge things sort of based on the sort of scale or response latencies and things that you actually need. But right now, we're not prepared to support the exact working functionality, and there are definitely edge cases and things that haven't been fully implemented, which you will hit quite quickly, I think, if you did deploy into production or attempt to deploy in the meantime. But please do reach out, and we can figure out the timeline that works for both of us. And in terms of migration, James, did you want to quickly touch on that?
Yeah, I certainly can. So I think, first of all, please do rest assured that version 1 of XTDB will remain stable and supported with security and bug fix releases for the foreseeable future. So we are more than aware and very grateful, in fact, that we've got a vibrant community and existing install base. So yeah, not going to be left out in the cold, should we say. If you do have, as Jeremy says, if you do have a production installation of 1X, you can sign up to our mailing list. So please do send us an email at hello@xtdb.com. And we can keep you informed of what's happening there. For migrations, so we'll be publishing migration tools and documentations on migration strategies soon. But as Jeremy says, please do also get in touch if you'd like our help doing so. So we do have a couple of labs tooling, a couple of labs tools at the moment. But again, with XT2, we wanted to settle down the migration target a lot more before talking about the migration processes themselves. Safe to say that has been kept in mind, though. And for those who want to do it, we're more than happy to support them through that.
Great. And yeah, there was a question about hosting options and will we offer a cloud service? We do want to sort of collect names and requirements of people that would like us to provide a cloud service for XT2 in the future. It's certainly something we're interested in doing. Yeah, right now it's not the priority, so we don't expect to see a SaaS portal imminently. But yeah, there is a wait list which you should be able to find in the docs. So I think I need to restore that. So I'll do that straight after this. So you can sign up to let us know that you're interested in that.
Cool. I should say I've noticed we are at 5 past the hour. I'm more than happy to sit here and answer questions for us within reason, as long as people are asking them. If you do have to shoot off, thanks very much for joining us. It's been great to have you on the call. And of course, we'll release the remainder of the Q&A as part of the recording, so you can catch up with that later if you'd like. Sorry, Jeremy.
Well, no, that's it. So yeah, we'll pause, end the recording, and well, actually, no, I'm sorry, we're not ending the recording. We're just opening up opening up for any questions. Yeah. So yeah, as James said. Is there any other questions? Martinez asked, do you have plugins such as Lucene in version 1? Yeah, do you or do you expect it to be external? Like a full text search, for instance. Yeah. So maybe that would be the question. Like, how would you address full text search in this architecture?
Yeah, so in a similar kind of way to V1, we would be looking to from the write ahead log to be able to plug in things like full text search. It may well not be Lucene in the same way, because obviously in version 1 it was very much about the individual nodes that all kept a Lucene index of their very own. What I'd like to be looking at here is more around how we can write a full text search plugin that's closer in nature to how an XT2 cluster now looks. So similar to using something like, for example, Elasticsearch or the like. Again, very early days for that as yet. I'll hope to have a more concrete answer in the not too distant future.
One of the things I have noticed with Arrow is you can sort of look for any problem. So if you have like a geospatial problem, or maybe a full text search problem, you type in that plus Arrow, and someone out there has come up with an Arrow format or like a way of doing it. And this is one of the sort of things that excites me most about Arrow, is that we have the potential now to sort of plug in multiple complementary storage technologies and processing kernels and give you access to them via a unified facade. So in the long term, I think that's the real potential of Arrow as an open format, and I think that's how I imagine these things will materialize in full course. And you see this with big data tools and Parquet, where you have multiple query engines operating on the same data. That would be a nice point to get to. Rahul did ask selfishly for the Clojure community, and for him, any hope for the client libs to natively support Babashka?
Let's see, why not?
Yep. So I guess currently it's
bring out the. Oh, sorry, Joe.
No, I didn't mean to interrupt you, but currently the Clojure client does depend on like a Java data structure to generate things. So I guess that would be difficult to port to Babashka, but as we roll out the JSON support, it should be more feasible.
I don't know. I mean, I'd probably target the HTTP server directly within Babashka.
Yeah, with JSON or
I mean, either
exactly,
JSON or transit.
Yeah, so it would be slightly different to the current Clojure client you download now. But yeah, would definitely like to make it happen, Rahul. Thank you. Yeah, please do post questions in the forum. Someone asks, Tyler asks about those Arrow slides. He says, I would love to hear you talk about them. So I don't know if you want to go back and do a quick bit on that, or
yeah, more than happy to. Should we take other questions, and then I can I'll go through the Arrow slides for the folks are still about.
Yeah. So for full text, are you aware of Yelp's net search? Seems like a match. No, I haven't heard of that. Thank you for the pointer.
No, thank you for the pointer.
And I think that's it for other questions. So yeah, we can have a quick diversion, and then maybe back to the end for any other questions, and then we'll finish.
All right. So let's say Apache Arrow stores all of its data within vectors. So what this means for us is breaking our documents down into each of the individual attributes. So in this case, we can see, first of all, two different types of vectors. So they split them up into fixed width and variable width. And so fixed width is all things like sort of integers. UUIDs also come into this category as a fixed width vector. You've also got fixed size lists and various other things. But in this case, what we're doing is essentially transposing the data that we get in our input maps. So you'll see here in this example, we turn a vector of maps into a map of, essentially a map of vectors in the file. So we store all the A values, so 1, 2, 5, and then we store all the B values, 1, 3, 8. The advantage this gets us is that if we don't need the A values, we don't have to read them. So that cuts down an awful lot on the amount of data that we have to read. But also it means that we can go directly to the value for a given row. So, for example, if I know I need the B value from the third row, as in row index 2, I know I go straight to index 2 within the vector and I pull 8 back as a constant time lookup, rather than with a row-oriented database where you would have each of the rows within the file and have to scan to that point. Variable width works similarly. The addition here is the offsets vector. So what we do here is we essentially concatenates all of the values from all of the documents together. So you've got hello from XTDB in its data vector. So this is just a data vector of individual characters. And we then store with it an offsets vector, which you'll notice is one longer than the amount of documents. So what this tells us, what this offsets vector tells us, is that the entry for the first document here is between 0 and 5. The second is between 5 and 9, and the third is between 9 and 13. I'm now really hoping I've got those offsets right, just in case anyone's checking them. Yeah, I think I have. Cool. All right. Arrow also has native support for composite types as well, which we lean heavily on. What happens with structs is that we rather than having a vector of the first level, the transposition goes down to arbitrarily deep. So in this case here, we've got a vector of all the A's, but the A's in fact are then broken down into vectors themselves. So we've got A1s, we've got 1 and 3, and A2s, we've got 2 and 4. And no matter how nested that vector got, the structs will keep track of the children, the children within each document. Lists, you can look on this not too dissimilarly to variable width strings. In this case, again, we keep an offsets vector, and then we can cat all of the lists together. So in this case, it's saying that the first element has a list within it. The list is between elements 0 to 2. There we go. There is a typo on the slides. So that middle one should be 027 rather than 037. Oh, no, beg your pardon, 037. Off by 1 error. Yeah, between 3 and 7. And so the second document has the list, the values between index 3 and index 7. Man, these off by ones. They get us all. And finally, and I think we're probably the only people who use this vector within Arrow. At least it feels like that sometimes. This is the union vector, and we make a lot of use of this because we're putting dynamic data into Arrow. Most of the use cases so far, or at least most of the people that are public about their usage of Arrow, have a lot more in terms of strongly schemed data. Whereas we'd like that to be a bit more flexible. We're aware that sort of the real world is a bit more flexible than that. How this one works, if you'll bear with me. So in this case, we've got an A vector. That A vector can contain either, in this case, numbers or strings. So what we do is we split it out into 2 child vectors. We split it out into a vector of ints and a vector of strings, and both of those behave like they would have done on the previous slides. We then keep this extra bit of metadata, which are type IDs and offsets. So the type IDs here are telling us which of the child vectors the value belongs within. So in this case, it's int, string, int, int. And then offsets tells you the offset within the child vector for that particular row. So in this case, if we were to look up the value that has A5, so index 2 here, the third within the list, we look at the third type ID, which is 0, and we look at the third offset, which is 1, which tells that this is within the first vector, the int vector, and it's offset 1 within that vector, so second position. So this does introduce a little overhead, but again, this is one of the things that within XT we do try to minimize. So any time that you do put monomorphic data in data that's all the same type, we've got optimizations in place that will avoid using these unions if at all possible.
isn't it? So there was a question from Steph earlier about sparse data, sparse handling, and I guess you don't cover it here, but there is in Apache Arrow a good support for validity bitmaps and run length encoding of those bitmaps to make storing lots of nulls cheap, and also storing lots of columns implicitly cheap, because the columns are in different files. So yeah, just thought I'd add that. But yeah, I think we're good. Over to you, James, to wrap up.
Excellent. Yeah, as always, just want to say a very big thank you for joining us. A big thank you to everyone who's fed into the XTDB feedback process so far. And please do keep those thoughts and suggestions coming in. Have a great Christmas, and we'll look forward to seeing you in the new year.